Welcome on stage, Frederik Kötz from Glassomer. Yeah.
Thank you. Thank you very much.
And one brief word, you are into glass?
We're into glass.
And go on, you got 5 minutes of presentation time and 5 minutes of questions right after.
Okay.
Your time up is 12:31.
So thanks very much. My name is Frederik Kötz. I'm the co-founder of Glassomer, and we work with one of mankind's oldest materials, and that's transparent glasses. Why do we still use glasses? Glasses have a very long lifetime. They are thermally, chemically very resistant. They have pleasant haptics. You can easily recycle them. You just basically grind them back to sand. But most of all, they have an outstanding optical transparency. So these properties make glasses very interesting for all kinds of applications, not only in everyday life, also in high-tech applications, optics and photonics, data transfer. Just think about glass fibers for high-speed internet, medtech technology, or chemistry. So in terms of material properties, glasses really surpass polymers in many aspects. And maybe you will be surprised if I tell you that the pure material costs for glasses are also way below the material costs of polymers. And this brings me to the question, why do we still use polymers in so many areas, like for example for the fabrication of smartphone lenses, where glass would have the superior material properties? And the answer for that is quite simple. Processing of glasses is just way more complex and also way more expensive than processing of polymers. Has any one of you ever shaped a glass at home? Yeah, probably not. The reason for that is quite simple. If you want to build a big object, you need high temperatures, and if you want to create tiny structures, you need etching processes with hazardous chemicals. And this problem with the shaping is also the reason why we haven't seen glasses in 3D printing so far. And that's exactly where we come in. We have developed and patented the Glassomer process, which combines the superior material properties of glass with the low processing costs of polymers. And therefore, we have developed new materials, which we term Glassomer. So they come as a liquid, a paste, or a solid. And you can basically process Glassomer like a common polymer. So you can 3D print it in a benchtop 3D printer. You can use it for casting. You can mill it. You can drill it. You can even structure it using high throughput polymer structuring technologies like, for example, hot embossing. When you're done with the shaping process, then the part goes into the oven and is converted into a real glass. This transformation takes place at temperatures way below the melting temperature. This is why this process can further save energy. What you get in the end, this is not something like glass. This is a high purity glass with the same material properties. So we have funded the company in April last year with public funding from the government. Who are we? We are a group of 4 people. We basically have everything from crazy scientists, process engineers, to organizational talents. We have an international patent on the technology, and we have also registered for the trademark Glassomer. So we are focused on the B2B market. Our customers are small, medium-sized to large companies who want to improve their products and processes by our products, but especially by our expertise in the field of material design. So in October last year, we started to sell prototypes, small series, and the material for R&D purposes to kind of bootstrap our company. We also do feasibility studies, which lead to a sub-licensing of our patent or the development of joint patents of the developed processes. And we are currently in our first funding round and in discussion with strategic investors. In the next 2 years, we will validate our technology in different segments with our partners. And once the appropriate partners are on board, we will scale up our process, rent new office and laboratory space. So our mission is the development of a new technology, which on one hand allows to 3D print glasses for the first time with high resolution, but it has the potential to revolutionize mass market manufacturing of glasses to make it cheaper and more energy efficient. What we are currently looking for are partners and customers who have market access in their specific fields. So for example, optics, photonics, chemistry, or coatings. And if you are interested in our technology, I would be very happy if you would visit us in the startup area. And with this, I want to thank you for your attention, and I'm happy to take questions.
Cool glass stuff. Michael, what do you say?
Well, I think it's a very interesting project what you guys doing there. So one question towards the platform you want to distribute to your, or you mentioned partners. Are you working with 3D printing manufacturers directly, or so you're looking for the platform to use your material?
So we talk to 3D printing companies because we are material developers. So it's basically a chair with 3 legs. You need someone who can do the upscaling of the material. You need someone who does 3D printing, has access to the machines, and we're kind of the people who develop the formulation for specific material printing technologies. But this technology can do more besides 3D printing. So we are currently strongly discussing with partners in the field of injection molding. So we have thermoplastic variations of this material, so you can basically remelt and use it in high throughput injection molding systems. So this is why we also talk to other people in fields of optics, for example.
Right. And in your opinion, what is the best technology to use your Glassomer material in additive manufacturing?
It depends on what you want to do. If it's high throughput, really high amounts of very tiny glass parts, I would go for imprinting technology. If it's a fancy structure, which cannot be fabricated with classical technology, 3D printing is the way to go.
Okay, so let's assume I have an idea for an application that requires glass. How do we start? What are the next steps?
Yeah, so normally it goes in some escalation steps. So normally we start with a prototype first because people want to show something in the company, and then normally it goes to feasibility study, and then we go to bigger projects. And normally, during the course of these projects, we start the discussion with strategic investors in how we can upscale these things.
So every time I have an application right now, you would also need to have someone to fund the project for you.
And so we have a public funding at the moment for 2 years, which gives us the freedom to kind of select, because we got a lot of different areas who came to us and asked, yeah, can you do this? We have a lot of ideas what we would like to do in class, but was not impossible. Was impossible to that point. So we're kind of screening at the moment, but several fields I mentioned kind of stepped up.
So have you identified any high potential verticals that you are focusing at, or are you just floating around doing everything for the time being?
No, so at the moment, one very, very important thing is with one strategic investors that's really focused on injection molding of glass formulations to go for high throughput. But during the course of this project, 3D printing also pops up.
In 3 to 5 years, are you going to just mostly be selling Glassomer? Or is your business model still project work, R&D, or eventually you just want to be selling the material?
It depends on how well it works. If we want to sell it in 2 to 5 years.
Not the company, the material. The material is is your business model eventually to just sell Glassomer?
Sorry, I got that wrong. No, so the main part of the business model for the upscaling is the sub-licensing contract. So I think it depends on the scale which you sell it to. If it's really going for high throughput, you need a partner who does the material, and then we give sub-licensings for the specific fields.
Okay.
Let me take Anna's question one step further. Like, what's the killer application that you see first? Like, what's going to bring you into volume production?
Yeah, so one thing which came up was a lot field of optics and photonics, structures which are difficult to fabricate or very, very cost intensive to fabricate. What you can see, for example, down here, this is a diffractive optical element with 16 layers in glass, which has a layer thickness, for example, of 250 nanometers and a lateral feature size of 1 micrometer. This is nearly impossible to fabricate with classical glass processing. It's very easy to do in polymers. I think I don't have to tell you that if you want to shoot something with a laser beam and this thing is made out of polymer, it's gone afterwards. So these are applications we are strongly focusing on at the moment.
Great stuff. This was number 2 of this year's Startup Award pitches, company called Glassomer. Thank you very much.
Thanks.